so we need to graph y equals 4, x equals 1, and x equals 6. Okay, and so the area that we are going to rotate is this. Okay with the picture? Okay, and then we're going to rotate it around the x-axis. So if I do that, this point, go to about there and then come back. Drawing a few of the circles. Now since we rotated it about the x-axis, a horizontal line, that means it's going to be dx, and our limits of integration are going to come from the x values. So 0 to 6, smallest to biggest. And still okay?
Oh, so it isn't washer method.
This one's just a disk, because there's not any. Washer means that there's going to be like a hole in the middle.
Okay.
Disk is like, it's solid. Like if you took this area and rotated it, there's no gaps in it.
Okay, I was looking at the little gap between 0 and 1, so that's why I was confused. But that would have been if I was rotating around the y.
Correct.
Okay,
Yes.
never mind.
Yes, sir.
It would be 0 to x and not 1 to x, or
Yeah.
1 to 6.
Yes, thank you. It should be 1 to 6. I think I did the opposite of what Solo did there. Okay, you should have an infinite number of infinitely thin circles, so pi r squared. And of course the hardest part is going to be finding the radius of these. But this one, the radius of all of our circles looks to be 4. So this is 16. To integrate 16, you get 16x. And one time you should plug in 6. I'm still trying to do 0 there. One time you should plug in 6 and get 96. And the next time you plug in 1, we subtract those, and so you end up with 80 times pi, which is where I got that as an answer.
Okay.
Now, probably the biggest thing that I'm going to try to lecture you guys on later on is these pictures, especially the harder questions. Like if your picture's not set up very good and it's too hard to read, finding the radius of some of these is going to be difficult to compute. But in this question, I need to take my own advice because I almost said 0 a couple times.